Welcome to Heeks and Draconies, here be dragons. So today I'm doing a reaction, but not to like a YouTube video or anything. I'm doing one to some new scientific research. And I just found this a little bit ago. It came out yesterday, so I'm a bit late, but haven't gotten a chance to take a look at it. I figured I would just do it here, live. So this is from UC Santa Barbara, and it's in the current. So, mapping space, the largest map of the universe announced. In the name of open science, the multinational scientific collaboration, Cosmos, on Thursday has released the data behind the largest map of the universe, called the Cosmos Webb Field. The project, with data collected by the JWST, consists of all the imaging and a catalog of nearly 800,000 galaxies, spanning nearly all of cosmic time. So, wait. This is all the data for 800,000 galaxies? That's pretty insane. I'm just scanning through here real quick. If you had a printout of the Hubble Ultra Deep Field on a standard piece of paper, I'm sure you've all seen the Ultra Deep Field. It's like 10,000 some galaxies all in one image. On a standard piece of paper, our image would be slightly larger than a 13 by 13 foot wide mural at the same depth. That's pretty insane. Huh. Okay. Where is it? Oh, here we go. Browse interactively. Check it out. The FITS map. All right, so here's our image, and this is 800,000 galaxies. Oh, here we go. Okay. And this is like a stitching together. So you're going to have some little areas here that aren't fully in. This is what flat earthers call CGI. Even though that is absolutely not what's going on. Oh, wow. How far in can we go? All right, so I think I'm, I think I'm at like maximum resolution here. But look at this box down here. Like that little teeny tiny box, that's what we're looking at. Like all these galaxies and stuff. Holy crap. Wow. Like the size of it is just starting to like blow me away. Look at all like, they're all galaxies. The darker, redder ones are much older and much further away. Now, what we're actually looking with these spikes is the, I guess you'd call them like the struts on the JWST that holds the mirror up. And that's what causes the spikes there. Just if you're interested. All right, so we have settings here: brightness, contrast, hue. Okay, we can zoom in, we can search. All right, and okay, here's all the imaging. So we've got the near infrared and mid infrared. We got RGB, standard red, green, blue. Okay. Just to kind of explain these here. So like NIR cam F115W, that's going to be the near infrared, and this is going to be 115 would be the micrometer, the wavelength of light we're looking at. So 1.15 micrometer, and it's a wide image. And that's for the rest of these too. So this would be 1.5. It's like in that range. So 1.5 would probably be like 1.4 to 1.6, or, somewhere in that area. So 2.77, 4.44. And then we've got mid-infrared. So this is 7.7. And see here, we can take a look at. Oh, so we've got, okay. So we've got the RGB here that we can look at. And then we can switch over to 1.15 and take a look at that. So I can take a look at this star right here, actually galaxy. And so now we can look at the different wavelengths. And different wavelengths are going to let different amounts of light in. So light can penetrate different things. So we can actually look behind things. So as we look, if we watch right here, we can see how this changes as we go through the different wavelengths of infrared. Which is pretty cool. Excuse me. Then we've got detection and segmentation. So detection, let me try and think how to explain this. So detection is just kind of like, here's an object. So it'd be like, here's a galaxy. Here's a galaxy. But segmentation would come in and sort of detail out like exactly where the arms and everything are at. So actually, let's take a look at this. So we go by detection. It should be giving me, yeah. So we can see basically the light's kind of turned up and we can see an actual object here. We can see these objects. Now we go to segmentation. That should give us, yep. So you can see it's actually all the like the entire object is highlighted. So you can see kind of the actual structure of it. All right. Regions. So these regions here are by like different surveys and stuff. We've got Cosmos, which is what we're Cosmos 3D, which is just like big section of the sky, which has been kind of imaged and stitched together. These are all basically imaged and stitched together. Primer, I think that is, what is that? Public release imaging, extragalactic research, and that would be near infrared. There we go. And it's covering this area of the sky right here. So we know which areas we're going to look at, and I'm assuming we can, yeah, these are areas, some of them overlap, so I'm sure the data is all combined within. We've also got Scuba 2, which I don't know much about that, but I think that's from the James Webb Telescope. All right. And then catalogs. So, let's look at this. The catalogs, so we've got Spec Z. This is going to be all the redshifting of light. And redshifting basically lets us look at how far away something's gotten over time. I guess that's the best way to explain it. It's the light basically gets stretched out as an object travels, as the light travels, I guess you could say. So we look at Spec Z. Here we go. All right, so we have these objects here. Here we go. So that gives us, here we go. So we get all the data on this object for the redshifting. And that is, oh. This is a lot of objects. Is this for all of them? It can't be. No, but that's a lot of them. My computer's like chugging away here, and I've got an RTX 5070, and I'm still in an older i9 9900, but still, it should be fine for imaging. It's kind of chugging away. My fan's going nuts. Photometric catalog. What is this exactly? Is this? This is like every object here, isn't it? Oh, oh. Okay. So we've got all the spectrums. We've got all the observed wavelengths, and oh my god, the amount of data here is. Oh, wait a second. This is for like, is this for every single object? Like every single thing in this image here? Yes. Holy crap. Dude, this is awesome. Got like full, like, all the wavelength data, all the spectrums and everything for 800,000 different objects, or galaxies, basically. Holy crap. It's every single object. My computer's, it's really like, that fan's going. Wow. I don't know if it's my browser that's doing it or if it's my computer. I mean, my computer, obviously, because it's really heating up. But, yeah, this is every object. Can we get, oh, what this is? This one doesn't, yeah, because this is a much closer star. So we're not going to have data just on a star. These should all be galaxies. Every single one of these is a galaxy. Now, think about this. In the Milky Way, just our galaxy, there's more stars than there's grains of sand on the entire planet. Each one of these is like another Milky Way. A lot of these don't even exist anymore either. Like, we're looking back, like, nearly to the start of the beginning of the universe. It is just phenomenal, and it's all here. It's all free. Like, holy crap. Wow. I need to turn off the photometric because this is really taxing my computer. But holy crap, just what you can do with this, like, it's not, you don't have to be a researcher at some university or something that has a massive budget to get this data to do real research and stuff. Just regular old astronomers can do this. Just people sitting in their homes have access to this data. This is incredible. Like, just the scale of it. Why is it all coming up with all these numbers now? It's like, I'm not sure what I turned on or something, but actually, I'm not quite sure what they all are. Let's, can I redo this? I just want to see the image here. Ooh. Oh, okay. I see how this works. Yeah, I'd have to go back like every single click. You know, it's map back here. Okay, this is, oh, okay. Is this all the data right here? Or is this, I think this is just the application. Okay, never mind. Okay, there's the mini map again. Well, we'll just look at it this way. And, it's just, wow, I'm sorry I'm just, like, quiet right now, but the immensity of this, you know, like, the Hubble and stuff, when you look and it's like just like this little area right here, the amount of galaxies right here is incredible. These are all galaxies, and okay, so it is still, so we do actually get a lot more. Okay, I didn't realize how deep the image should go. Look at that. That's actually starting to resolve. And we look at this box down here, like every one of these is a galaxy. It's just immense. I mean, wow. All right. Okay. Well, I think that's it for my review. You guys definitely need to take a look at this and try to wrap your heads around it. Hopefully you found this interesting. I'm just in awe right now, so I don't really know what more to say about it. I'll go into it in depth later on if you guys would like, but I just want to let you know about this. People told me to take a look at it, and I am very impressed. So this is the largest map of the galaxy ever. All right, have a great day.